Now we're doing sketching linear graphs, this time using one of the methods being the gradient and the y-intercept. Now, in order for us to be able to do so, we need to have a number of things set up first of all. The first thing is that we're actually talking about an equation that's written in what we call standard form, okay, or as also referred to as the gradient intercept form. Now, what we mean by that is the actual equation is written in this form here, y equals mx plus c. It has to be in that standard form, and what that really means is that we've got the y by itself. There's no x term with it, there's no number with it, there's no multiplier, coefficient or anything with it. The y is on its own. So if you look at these first three equations here, they are all written in what we call standard form purely because the y's are on their own. The fact that it's on the left-hand side or right-hand side makes no difference, but we actually just do it on the left to keep it as simple as possible. Two things that we need to find and need to state for each of these, okay, for all of them. We need to state what the gradient is and also what the y-intercept is. And we can only do that when they are in standard form. And of course these three equations are. Going by what we looked before, gradient, the m, is the number or the coefficient of the x term. So you can see with the question number one that the number that is with the x is this negative 3. So my gradient becomes negative 3 over 1 or simply just negative 3. Okay, more often than not we can just say negative 3. When we use it to graph, we would use negative 3 over 1, and the y-intercept is the number 2. In some books, and in our textbook, what you'll often see is the standard form y equals mx plus c. They actually use a different letter for c. They put the letter b. But honestly, it doesn't really matter so much, but it's the one that's not with the x in that sense. Look at number 2. Y equals 7 subtract 4x. Now the gradient again is the coefficient of the x. So you can see in this term here, there is the coefficient of the x being negative 4. And if I wanted to write it as a fraction, minus 4 on 1. My y-intercept is the other number. And in this instance, it's the number 7 or positive 7. Question 3, standard form. Yes, it is. The gradient, what number is sitting in front of the x there? Well, because there isn't a number that's visible, it must be the positive 1. And our y-intercept is negative 1 in this instance. Looking at these two equations on this side, the first one, yes, it's in standard form. Y is on its own. It's missing a number on the end. Doesn't matter. It's still, we need to state the m. We still need to state the c. M being the coefficient of the x, in our case negative 5 on 1, and c being the number on the end or on its own, and in this case there isn't one, so it's actually 0. So we could have put plus 0 there. Obviously that wouldn't make a difference to the graph, but we don't need to write it. Second one, number 5, you can see that we've actually got a coefficient of y this time. We have to get rid of that. So we have to actually get y on its own by almost solving an equation for the letter y. So it means taking this 2 and getting rid of it. And the only way to get rid of it is to make it a divider. So what happens is that this particular number 2 has to go to the other side of the equation and become a divided by 2. So the way we would write it is y equals 5x subtract 4 all divided by 2. Now to do it like that, it looks a little ugly. I can separate the two terms on the top and have 5x over 2 subtract 4 over 2. It allows me to look to try and simplify. I can't simplify the gradient fraction, so I leave that as 5x on 2. However, 4 on 2 simplifies just down to 2, so it becomes subtract 2. Now that I've got it in standard form, as in I've got my y on its own, I can now state the gradient being the number with the x, and in this case the number is a fraction, not just the 5, but the actual fraction of 5 over the 2. So you can see it is this entire fraction here that belongs with the x. So that's why it becomes a 5 on 2, and my y-intercept is simply negative 2. Again, 6 and 7, basically all it is that they are not in standard form. We need to get them in standard form. I need to remove this adding 2x in order to leave the y by itself. So in order to have y on its own, this adding 2x will go over, join on with a 6 and become a subtracting 2x on that side. Now I've got y on its own. I can state my m to be the coefficient of the x, which is minus 2, and my c to be the other constant number there, which in this case was 6. Number 7. It's almost in standard form. What we've got though is this negative value. Really, it's like having a minus 1y. So we have to remove the y. What's it doing? The opposite? Well, we need to make sure everything gets divided by minus 1, because minus 1 is a multiplier to the y. Everything must get divided by minus 1. So really what happens is similar to example 5 before. I separate them both as such and do my little calculations. 4x divided by minus 1 will simply just becomes minus 4x. And negative 3 divided by negative 1 becomes plus 3. And if you look back up to the top here where I've just circled, all that's happened, because I've turned a negative y into a positive y on the left hand side, my positive 4x has become a negative 4x, and my subtract 3 has now become an add 3. So again, stating my m to be the coefficient of x, negative 4, and my c to be positive 3. Now I'm going to use them to sketch. The first graph we're going to actually look at is the graph that actually goes through our origin. And what I mean by that is it goes through there at 0, 0. Those graphs will be in the form, as we can be seen here, y equals mx. So what they're actually missing there is this plus c on the end, or in our case, they've got a plus 0. So really what we're looking for is a graph that is of this form, and we go about sketching it. Again, we put it into standard form. Y equals mx plus 0 in this case. We look at this example 1, it's in that form. So let's state down our m's and our c's. Well, we know the c is 0. It's not there, so we can put it there. Our m in this case is minus 3. Because I'm using it to sketch, I'm going to actually state it as a fraction of minus 3 over 1. And if we can remember, it refers to a rise being the top number and a run being the bottom number. So when it comes to sketching, 1 is plot the y-intercept, or the c. So I go to my graph and I actually plot the y-intercept. So if I look at my y-intercept, I go across here, I know it's 0, and I go and I plot it. 0, and I label it, because it's a point, I label it 0, 0. My next thing is to go and use the gradient. So the next bit, number 2, says use the gradient to find another point. Now my gradient is, as mentioned before, negative 3 over 1. And what that means is that from any given point that I know of, I can come down 3 and run across 1. So if I look over here, my 0, 0 is the point that I do know. I can come down 1, 2, 3, go across 1, and I end up with what is my second point. I label that second point as a coordinate, knowing I've just come across to x is 1, and I've dropped down to y is minus 3. I now go and try and draw a nice straight line, we'll see how we go, that goes through those particular points. That's how I sketch it. I now go back and I actually write the equation y equals minus 3x. I should have arrows on the end of my graphs as well to show that it goes on. Y equals minus 3x. Another example, it's asked us to sketch this one. I can't sketch it, I need to put it in standard form first of all. So I need to rearrange a few things. Okay, first thing I need to get rid of is this 5x. On the left hand side, it's an adding 5x. So I'm going to take it away as a subtractor. Left with my minus 2y becomes 0, subtract 5x, leaves me as so. Finally, I need to get rid of this negative 2, which is a multiplier. So it goes across and becomes minus 5x, which is already there, dividing by negative 2. The two negatives, as you can see there and there, will cross off, and 5x on 2 simply stays as 5x on 2. And you can see it would be, if I wanted to, plus 0 on the end. So now what I've got is my m and my c. Well, my c is 0 because it was plus 0, and my m is positive 5 on 2. I go and plot. Step 1, plot my y-intercept. Well, I know that to be 0, 0, and label it. Step 2, use my gradient to rise 5 and run 2 to find my second point. So from my 0, 0 point, I go 1, 2, 3, 4, 5, across 1, 2, and there is my second point. Again, get my label it first. Now I've come across to 2 and up to 5, and I have my second point. I get my ruler out and I try and draw. That's not working. Try and draw again. There we go. And that's close enough, I suppose. Yours will be a lot neater. And again, arrows on the graph, and label the equation 5x minus 2y equals 0 on the graph. Third one, it's in standard form. This time we've got a c on the end, but the steps are exactly the same. M, C. Let's state my m to be 2, or 2 over 1, and my c to be positive 1. Step 1, go and plot my y-intercept. Well, in this case, it doesn't go through 0, 0. It goes through 1 there. So I'm going to label that as 0, 1 as my y-intercept. Next, use my gradient. So from that point, I'm going to go up 1, 2, across 1, and there would be my second point, which we know now to be 1 and positive 3, because I've gone across 1 from 0 and up 2 from a height of 1. I then get my ruler and I try and draw a little beautifully straight line, arrows on the ends, label the equation, y equals 2x plus 1. Next one, again, same thing, it's not in standard form, we need to get it there, so let's rearrange it. First thing we'll get rid of is this 2x to the other side, it becomes 6 subtract 2x, and then finally I'm going to divide both of them by 3, so I'll divide that by 3, and the 2x by 3 simplifies to 2, 6 divided by 3, and negative 2x on 3 stays that way, MC. Now I've got my standard form, my m being the minus 2 over 3, the fraction there that is with the x, okay, and the c being the number 2. Oops, number 2. Go and plot my y-intercept of 2, so there it is there, and I'll call it 0, 2 as a point. Use my gradient, which is negative 2 over 3, which means come down 2 and then run 3 spots to get my next particular point. Label it. In this occasion, it's going to be 3 and 0. Get my ruler and again try and draw a nice straight line, like so, similar to before. Oops, arrows on the ends. And label the equation with the original looking 2x plus 3y equals 6. Good luck with sketching linear graphs. It's exercise 5.6. See you in the next one.